Hi, welcome to the Olympiad geometry. Let's continue our study on 9-point circle. Here is a problem. G is centroid of triangle ABC. P is any point on circumcircle of triangle ABC. Connect PG. So here is AB triangle ABC and the circumcircle. P is any point on this circumcircle. Connect PG and extend to Q that GQ equals to half of PG. Shows that Q is on 9-point circle. In previous video, we already proved that a 9-point circle is also the circumcircle of triangle FDE, right? DEF as the midpoint of BC, AC, AB respectively. So we just need to prove that FDEQ is a cyclic quadrilateral. To do that, first we need to figure out how do we find the Q, right? From the problem set that GQ equals to half of PG. GQ equals to half of PG. And because G is a centroid of triangle ABC, so we already know that AG to GD equals to 2 to 1. Look at these two. It basically tells us just to connect AP and QD, right? Because GQ to PG equals to 1 to 2, and GD to AG equals to 1 to 2, right? GQ to PG is 1 to 2, GD to GA is 1 to 2, and also angle AGP equals to angle DGQ. So we know that triangle AGP is similar to triangle DGQ, right? And based on this, we know that angle, because these two are similar, and this edge reference to, the edge GD is reference to edge GA, right? DQ is reference to AP. So we know that this angle equals to this angle. So that angle GDQ equals to angle DAP, which means QD is in parallel with AP. Right, that's information we can get. Whether it's useful or not, we don't know. We just try to figure out as much as possible we can find with the problem set, right? And now we can just take a look at the questions that we want to prove Q is on the 9-point circle, which means we want to prove that FDEQ is a cyclic quadrilateral. So we connect FDEQ. Right. To prove that it's a cyclic, we just need to prove that angle FQD equals to, so I just make a question mark here. The angle FQD equals to angle FED. Right, we just need to prove that FQD equals to FED. So angle FQD can be rewritten as angle FQP plus angle PQD. Right? FQP plus PQD, right? That's angle FQD. And PQD equals to angle APQ, right? So it can be written as FQP plus angle Q APQ, right? So I can QPA, it's the same thing, right? So PQD equals to APQ. So let's just mark it here. Now we want to find FQP, right? FQP. FQP is FQG, and we already know that GQ to PG is 1 to 2. FG to GC is also 1 to 2, right? So FG to GC equals to 1 to 2. QG to PG equals to 1 to 2. And also angle FGQ equals to angle PGC, right? So we know that triangle FGQ is similar to triangle CGP. Right? Because this to this equals to this to this. And also they have the same angle here, which means we can simply get angle FQG equals to angle C. This one, this side, this edge, the GQ edge is reference to GP edge, right? FQ edge is reference to CP edge. So this angle reference to this angle, right? That means FQG equals to angle FQG equals to angle GPC, right? And we know that FQ is in parallel with PC, but this is enough, right? Now we know angle FQG equals to angle GPC, and angle GQD equals to angle GPA, which means angle FQD equals to angle APC, right? And because angle APC equals to angle ABC, right? So we got angle FQD equals to angle ABC. So FQD equals to angle ABC. And we know that FED are the midpoint of edge AB, AC, BC respectively, so that FE is in parallel with BC and DE is in parallel with AB, which means FEDB is a parallelogram, so that angle ABC equals to angle FED. Now we can see that angle FQD equals to angle FED, so FQED is cyclic, right? Because the FDE, the circumcircle of FDE is a 9-point circle, so we know that Q is on 9-point circle, right? So for this problem, it's a relatively simple problem. It's just we need to, because we already know that GQ to PG is 1 to 2, and we should be very sensitive to this 1 to 2, especially when we have the centroid here. We know that we have to use the ratio of the the property of the centroid, that AG to GD equals to 2 to 1, and the CG to GF equals 2 to 1, BG to GE equals 2 to 1. So we need to use that correlate to this GQ to PG equals to 1 to 2, right? Once we relate these this ratio together, we figure out the similarity of the triangles, and then we know the equivalence of the angles, and then we can eventually derive the final result. Okay, I hope you like this video. See you in next one. Thank you.